As usual, you're going to be with me, Mr. James Mwita, a science teacher from Shalom Pre and Primary School, a school which is located at Chamazi within Temeke district in Dar es Salaam. So, before I begin, I'll make sure that you have your notebook for taking short notes on what you're going to discuss. So have a notebook and a pen. I'm just giving you a few seconds to make sure that you have the required materials. Yeah, I hope now you have your pen and a writing material. That means in my son's notebook. And in today's lesson, you're going to discuss about calculating voltage. Finding or calculating voltage. The word voltage is not something which is new to you. It's not new in your ears. It's something we have been talking about in our previous periods. And also we divined. I remember we divined the word voltage. It is measured by what? It is symbols. The SI units. So, before going direct away to the formula of how to find voltage, let us try to remind ourselves about the voltage. What is it? We are going to see the short hints about the voltage, then we go to the formula, which leads us to get voltage. Voltage, first of all, you have to know what's voltage. Voltage is the force. Is the force that causes the flow of charges in a circuit. What causes the electrons to flow in a circuit? That force which causes the electrons to flow in a circuit is what's called voltage. That force which causes the electrons or the charges to flow in an electrical conductor or a circuit is what's called voltage. Remember, we discussed about the symbol for voltage. It is V. V stands for voltage. V stands for voltage. But also he said, if you remember, voltage can also be referred to as 1. Potential difference, PD in short, or also called electromotive force, EMF. So voltage, which is denoted by letter V, is also called potential difference. Potential difference in short, or the symbol for potential difference is PD. Voltage can also be referred to as electromotive force, where the symbol for electromotive force is EMF. So this one stands for, it's also the other name for voltage or potential difference. Because today I want to see how to find voltage, how to calculate voltage. You might be given a given equation in an exam. Any exam can be, even your assignments, class assignments you're being given, you can be given a question where instead of the examiner using the word voltage, he decided to use the word potential difference. Find the potential difference, or find the electromotive force. So when you meet these words in a given equation, find the potential difference, find the electromotive force, you are going to use the same formula which you are going to see when finding what? Voltage. Voltage is measured by voltmeter, electrical instrument which is used to measure voltage. SI units. Voltage is what? V, volts. The SI units of voltage is volts or V, volts. It is denoted by letter V. The formula for finding voltage, the formula which will lead you to get the answer when you have been asked to find the value of the voltage, voltage is equal to current times multiplied by what? Resistance. In short, it's written as V is equal to IR. IR means I times R. V is the symbol for what? Voltage. I stands for current. R stands for resistance. So with us, you are going to see some of the examples here. We are going to be given 3 examples here. Or we are going to do together with you 3 examples which needs us to find what? Voltage. Then after finishing the 3 examples, I'll give you an assignment. You go and try it at your own time and try to come up with the value of the voltage. Find the voltage in the figures which we are going to be given. The first figure is this one here. Let me draw it for you. Second figure. Our last figure C is given here. So let us try to find the values of the voltage in the three figures which have been given on the board. The figure A, figure B, figure C. So let us begin with figure A, finding the value of voltage in figure A. So solution for A. V is equal to IR. We have said V is the voltage which you are looking for, I is the current, R is the resistance. So, have we been given I from the first figure? Yes, it is there. I is what? 0.5 amperes. Remember, I is current. What of R? R, it is there. Yes, 10. V is the one which we are looking for. We have not been given V. So voltage is the V is equal to 10 or 0.5 I times 10. Ten times 5. But remember, you have got one decimal point here. 0.5. So you should make this one also to be, should put our decimal point in our fifth here. So we count from your right. So our decimal point will be here, because we have one decimal point here. So the value of the voltage is equal to 5 volts, or it can be 5V. That's the answer for our first figure. Second figure B, finding voltage. As we have said, V is given by IR. From our second figure, if you studied very well, we have been given 3 resistances which are in series. 3, 7, and 2, all of them, they are in series. And when you, to get the total value, or to get the total resistance in series circuit, you add up directly. You add 3 to 7 plus 2. So, from our figure, we can easily get our R, which is 3 plus 7 plus 2. Which is 12. We have been given I in our figure. It is here. 2. So we are looking for the value of V which is missing, which we have not been given. V. Question mark. That's what we are looking for. V is equal to IR, where our I is 2 times R, total R is 12. So you multiply 12 by 2. 12 times 2, or 2 times 12 is 24. You cannot leave your answer hanging like that one, because it has no units. You have to write the units to show that you are calculating voltage. So, voltage in the given circuit in B is equal to 24 V, or 24 volts. Can use or. Should I write V, it's also acceptable. Any of the two. Any of the two answers is correct. Here you have written units in full. Here you have written the units using the symbol. Our last question is this one here. where you have been given a combination of series and the parallel resistances. You have been given current is 4. You have not been given voltage. V is equal to IR. Exactly. I is equal to 4. R is what you are looking for. You have to find the total R. You have to find the total R here. V, we don't know. Now let us find total resistances in the figure C. Because we have parallel here and we have, so a combination of parallel and a series. So total resistance, total R, equal to 4, you add to what? The total resistance in the parallel part. How do you get it? 2 times 2, this one, divided by 2 plus 2. Where R is equal to 4 plus 2 times 2, 4. 2 plus 2, 4. 4 divided by 4 is 1. 4 you divided by 4 is 1. So here our R is equal to 4 plus 1. Our R is equal to 5. So the value of R here is 5. Now we have our total R, we have I. Let us look for V. V is equal to I, which is 4 times 5. V is equal to 20. So voltage in figure C is 20 volts. Am I clear, class? We are done with the 3 examples which have been given on the board, asking you to find the total voltage. Figure A, it is here. Figure B, it has been done here. And the last figure where it has got a combination of parallel and series, we have left the answer which is there. Now let me give you one question. You try to do it at your own time. I'm going to give you a question which is going to be in a way the problem doesn't have the figure. Good. There is assignment here. The assignment which I've given you is just in the form of what? In the form of word problem, where you have been given two resistors, each with 6 and 4. They are in parallel. They are in parallel and in series with another resistor which it is the value is 3. Calculate the voltage in the circuit if the current is 3. You've been given the current is 3. Try to do this particular question at your own time. Just have it in your notebook, then you will do it later. Let us now to try to wind up this topic. Let us try to wind up the topic. We have discussed about voltage. We have discussed about current and resistance. Because most of them we have been discussing about current, we bring in resistance, we bring in voltage. Now, what's the relationship behind these three things? Voltage, current, and resistance. They have something in common. So the relationship between voltage, current, and resistance can be well described in the Ohm's law. The relationship between current, resistance, and voltage can be described in Ohm's law. Can easily be described in Ohm's law. Now let us try to see what's Ohm's law. In short, Ohm's law is given by the formula describes what's Ohm's law. The formula describes what's Ohm's law. That can be stated this way. The voltage, the current flowing in a circuit is directly proportional to voltage and inversely proportional to resistance. The current flowing in a circuit is directly proportional to voltage and inversely proportional to resistance. So to wind up, or to put you clear on what's written here, that means if you increase voltage, voltage, which is V, the current will increase. But if you increase resistance, the current will decrease. That's zero. That's the sum. I'm summing up. I'm finishing up. Because if you go here, the current flowing in a circuit is directly proportional to voltage. That means if you increase voltage, the current will also increase. And inversely proportional to resistance, meaning if you increase the resistance, what will happen to the current? The current will decrease. Ohm's triangle. This sum up everything. VIR as our end. Voltage is equal to IR. I is equal to V over R. R is equal to V divided by R. Have this one in your science exercise books. And I try to attempt this question you have been given. Because of time, I'll end there. I expect to meet you in the coming period. But if there's something which you have not understood here, please, don't forget to ask me when we meet. That's the end of our lesson today. See you in the coming period. Bye-bye.